All right, starting with a monomial, we have, this is a mono just means one, right? That prefix. So all this is just a number or variable or a product of the two. Product of numbers and variables. So an example of a monomial, 5. The number 5 is a monomial, right? There's one thing there. Same thing with 5x. That is one, we actually consider that one term, one thing. So is 17xy. If it's just simply a product, it's just we just have one item, right? So a monomial is just when you have one thing. It's a product of numbers and variables. So one. Mono means, this prefix means one. What is the prefix, everybody? What does poly mean? Many, right? So really it's just going to mean we have many monomials. So what's this going to be? This is going to be the sum or difference of monomials. So actually what that means is you can call one term a monomial is a polynomial, right? They fit into each other based on our definition. So an example would be something like 5x plus 12, right? This is a polynomial. Well, we're going to give it another name in a second here, but this has two terms, right? So if you think about this, we consider this a term, and this is a term. So in this case, there are two of them, right? Two individual terms here. Same thing if you looked at 45x to the 7th plus 3x plus 3. This has three individual terms, right? There's one here, here, and here. So a polynomial simply means you're adding or subtracting monomials together. And degrees. So degrees of polynomials actually becomes important throughout the semester. It's going to seem like it doesn't mean a lot, but it actually comes up a lot. So let's start with the degree of a monomial. This is the sum of the exponents. Okay. So let's find the degree of each of these three examples, right? So it is simply the sum of the exponents of the variables. So what's the exponent on the variable here? Because there is no variable written, but there is an exponent. So that would be something like x to the first. So it can't be 1 because there's no variable. So it's 0, right? This would have degree 0. There's no variable, so it's going to be 0. So then what about this next one? This would have degree, what's the exponent on the variable? Well, it's a 1 here, so this has degree 1. Now the actual definition is the sum of the exponents. So what is the degree in 17xy? There you go. Our degree equals 2. This is actually going to be the less common definition. Let's make a note here. This is less common. We don't see a whole lot of monomials with multiple variables. It doesn't happen too often in semester 2. What we're going to see a lot of is polynomials with one variable. But let's get the correct definition down, and then we'll talk about really how it relates to us. So the polynomial definition for a degree is going to be the term, right? The individual part. You could also use the word monomial here. Term with highest degree. And when you just have one variable, let's put this in parentheses, and most of the time we are going to have just one variable. When you have one variable, this is simply the highest exponent. Most of the times, 9 times out of 10, we are going to have one variable. So you just look, highest exponent, that's your degree. That's really nice. So I only wrote 2 examples here of polynomials. So, and they actually both happen to just have one variable. So what is the degree of this first one? While we're looking at one variable, you just go to the highest exponent.
5x.
5x is not an exponent.
Oh,
One. So 1, you're just simply looking at exponents. So this is your degree. It's a first degree, or we'll change that vocab in a second. Okay, same thing here. You're looking at, so this is a term, that's a term, that's a term. So what's our degree of this polynomial? It's going to be 7 or 8. Which one? Think about what we said here.
7.
Highest exponent, that's it. You're looking at the term with the highest degree. So this term right here has degree 7. So this has degree 7. You don't add them up. At no point do we say add them up, right, for polynomial. That's our definition for monomial. You're going to get these confused at first, so just pay close attention. Polynomials, you look at each individual piece. Just find the one with the highest degree, right? Don't add them up. So let's put this to use. And let's put some examples up here. I just want you to find the degree. So just write a number for your answers here, okay? So part A, 5x squared. You're going to write a number for your answer. A squared b cubed. 3x plus 4x cubed. All right, let's wake you guys up this morning. Luke, what's our answer to the first one?
Second.
Second, yes. There we go. So, second degree. Timo, or Pete, if they're being multiplied together, oh, it's frozen. Add them up. Right? So with a monomial, you simply look at the sum of the exponents. That's how we define it, right? This is a monomial. This is one term. Sum of the exponents. That's how we define a monomial. This is a polynomial, which gave a different definition, right? You're looking at the term with the highest one. So let's break this one down. What is the degree of just this first part? Everybody call it out. 1. What's the degree of the second part?
3.
So you're looking at the term with the highest one for a polynomial. So that makes this one have an answer of
3.
There we go. Do that same thing, volunteer then for this next one. Break it down. What's the degree of this and then this? There we go.
3 and 9.
Okay, so then the answer would be
9.
9. Right? You look at the individual pieces, and then you look at the one with the highest degree. That's your answer. All right. So 9 times out of 10, as I said, you're just going to have one variable. So you just take the highest exponent. You're done. Right? That's going to be the majority of what we look at this semester. All right. So let's talk about naming these things. So we're going to talk about naming a polynomial in 2 different ways. Let's start with what we were just talking about, which is the degree. All right. So let's say we have degree 0, and then maybe let's create a third column and let's look at an example of this. So you have degree 0. The name of this is a constant. Can you guys think of an example that would fit this?
2.
Number 2 is an example. All right. This one comes up a lot. We've used this term before, constant, that word, we've used that before. I keep using it. Degree 1, we actually have used this one a lot too in class. When we were graphing straight lines, what kind of lines do we call those?
Linear.
We call those linear. And think about it, y equals, x plus 5 has degree 1. So we're going to say like x plus 5. Linear. All right, so 2 here has what seems like an odd name. This is quadratic, which you would think would be 4, right, with that quad up front. But this is 2. So an example would be x squared plus x plus 5. We are actually going to go up to 5, right? And then anything after 5 will just be, we'll mention that. So the next one, 3. You guys have a guess on what 3 will be? Cubic. Thank you. So 5x cubed plus x squared plus x plus 5. Cubic. This fourth one does actually make sense. So as I said, the quadratic is kind of a funny name for 2. The other ones make sense. This one is a quartic. It is a quartic. Oh, yeah, that's okay. I'm coming from my fault.
Okay.
So then you just need a 4th degree. So 17y to the 4th is an example. And lastly, as I said, we're going to go up to 5. Doesn't hurt us. Yes, you have to know these. Sorry, what did you say? Yes. Wait.
Quintuple.
Quintic.
Quintic. Just getting ahead of yourself there. Yes, you do need to know these. So then let's just say we had any number that's above 5, right? So if you just have a degree greater than 5, you're simply going to say, so if you had a 7 or an 8 or the letter n, you would say that this is an, kind of running out of space, this is an nth degree polynomial. So if it's a 10, you just simply say 10th degree. If it's an 11, you'd say 11th degree. Otherwise, we're going to use these words, right? We're going to practice them, get used to them. These first 4 we use all the time, so you can't get away from them. And then these 2 are just, they're not bad to know, right? So that's naming a polynomial based on degree. Let's name it based on the number of terms, right? So we should all know the answer to this first one. If we simply have one term, what's the name?
Constant. Oh, linear.
That's the degree. We're talking, like, what was the very first thing we did? Monomial. So there's just one item, right? So the prefix means 1. Okay, if we have 2, this is going to be, say it again? Somebody said it. What's the prefix for 2?
Binomial.
There you go. Binomial. If we have 3, it's going to be? And that's good. We're just going to leave it at that. So then, anything bigger than 3, so 4 and up, is going to be a polynomial. Alright, so we want to be comfortable with these. We have to know this vocab, right? Both for degree and for number of terms. So make sure you have that jotted down, and we'll just put that to use by applying this vocab. So who has our first one for us? Michael?
Degree 2 monomial.
Okay, so degree 2 is, what's another word for that?
Oh, a linear.
Don't listen to Spencer, he's lying to you.
Oh yeah, it's wrong. Quadratic.
Alright, next one. Lexi.
Quadratic binomial.
Binomial. Next one. Anton.
Quadratic trinomial.
And last one, there we go.
Quintuple polynomial.
All right. And we're gonna have just the perfect amount of time here to finish up. So standard form of polynomials, our last thing. Once again, more vocab, as I promised. Today is really just a vocab day. Standard form of polynomials, even if we don't get to an example, that's okay. Two things here. And this is going to be often what we have. We're going to have one variable. So if you have multiple variables, standard form doesn't make any sense, okay? So one variable, you have to have that. And then you write exponents in decreasing order. So if we just took some, let's say we took a cubic trinomial, so that could be something like 5 plus 3x cubed plus 2x, right? Cubic trinomial. This is not in standard form because the exponents are not decreasing. So this would be 3x cubed plus 2x plus 5, right? Now our exponents go 3, 1, 0, right? That's a decreasing order. Now, one more piece about this, and this, once again, the vocab we're using, we're saying it for a reason. It comes up again and again. This number up front is called the leading coefficient. And now is the time to talk about the vocab, although it won't come up until chapter 8, so in just a couple weeks. But this does become an important number to talk about, that leading coefficient. It's the number in front when it's in standard form. So 5 is not the leading coefficient. Regardless of how it's written, it's always 3. All right?